look at this problem. The first thing that we want to check now, anytime we have a definite integral, we first are going to have to check whether the integral is proper or not. Thinking about the way that I've written this function that we're going to find the antiderivative of, it has a continuity when x equals 2, because that would make us divide by 0. If I had written this integral such that I went from 3 to 10 instead of 2 to 10, this function, or this integral, is now proper. This is a proper integral because the discontinuity of 2 doesn't lie inside of the bounds. But I wanted to practice the improper integral, so I'm going to put my 2 back. The first thing I'm going to do, because it's improper, is go ahead and rewrite this as a proper integral, meaning this 2 is the problem, and I'm going to replace that 2 with a constant. And then we're going to take the limit as a approaches 2. And there's a subtlety here. And if I think about all of the numbers that exist between 2 and 10, all of these numbers between 2 and 10 are on the right-hand side of 2. So when we write this limit, we want to be careful to write the limit as a approaches 2 from the right. And it's from the right because all of those numbers between 2 and 10 are on the right-hand side of 2. I'm going to come off to the side and finish off the integral. And no, I'm not. We'll just do it right out. So I'm going to bring my limit along with us and make this the limit as a approaches 2 from the right, going from a to 10. But I want to rewrite this. So when I look at this integral and I'm asking myself, is it algebra, trig, or a mixture of stuff? It's algebra. My first line of defense for algebra is, can I make it look like x's raised to powers? And if I rewrite this, that can be x minus 2 to the negative 1/3 power. We could write a u substitution for this. I'm hoping that at this point we can sort of see that u substitution without writing it out, because this interior term is just x minus 2. It's a linear term. There isn't even a constant in front of the x. If I were to make x minus 2 u, du would just be dx. So I'm not going to write that u substitution. I'm just going to do it. So I'd have the limit as a approaches 2 from the right. And taking this antiderivative, I'm going to add 1 to the exponent. So negative 1/3 plus 1, or if I think about that 1, it's 3/3. Adding 1 to that exponent is going to give me a positive 2/3. I am looking at x minus 2 raised to the 2/3 power. And then we would divide by that new exponent of 2/3. And dividing by 2/3 is the same as multiplying by 3/2. Now I need my bounds because we were going from a to 10. Before I can evaluate the limit, I have to plug those bounds in. So I've got a approaching 2 from the right. When we plug 10 in, 10 minus 2 would give me 8. So I'll have 3 times 8 to the 2/3 all over 2, minus, when we plug a in, I'd have 3 times a minus 2 raised to the 2/3 all over 2. 8 to the 2/3 we can simplify if we want. This is the same as taking the cube root of 8, which would give me 2. And then if I square that, I've got 4. So this is 12 over 6. Sorry. This is 12 over 2, which gives me a value of 6. There's nowhere to plug that a in, so we don't need to apply the limit here. To this second piece, if I plug the 2 in for a, then I'd have 0 raised to the 2/3 power, and 0 to the 2/3 is 0. So my final answer would be 6. And if the question asked if it converged or diverged, then I would want to be sure to write that it converged. Or that it's convergent.